Alright, welcome to another video, and in this one we're going to be looking at the binomial theorem. So let's start with what the binomial theorem is. The binomial theorem allows us to expand any equation within a set of brackets. So for example, let's say if we were asked to expand this equation, a plus b, and all of that squared, well, using simple FOIL, we can deduce that this would give us a squared plus 2ab plus b squared. Alright, so we know that that's simple, and we know that if we had to the third power, which is the next power, is the same as saying a plus b times a plus b times a plus b. And again, expanding that out, we would get the answer is a cubed plus a squared b with a 3 before that, that's plus 3ab squared plus b cubed. But what happens when we suddenly get an expansion to a power like 10, for example? That's too big to try to do the FOIL method, because that would mean we have to do a plus b times a plus b and so on 10 times. That's way too long. And in a real IB exam, you can't do that because you would not have time. So multiplying that out by hand would take forever. So using the binomial theorem, it's basically a shortcut that would let us expand any bracket like a plus b to any power without doing all that multiplication. So firstly, the first step is that we need to know what our coefficients will be. If you see here, you can notice a pattern that there are terms and there are coefficients, right? So for example, in this second one, we can see the terms a and b, b and a, and then we have this coefficient, and in front of the a and the b, there are obviously ones, right? So how do we find the coefficient for any of these? Well, we use Pascal's triangle. The way we draw Pascal's triangle is that we first draw a triangle of ones, so all these are ones, right? And then in the next row, what we're going to do is we're going to add up whatever we have above in the row above. So for example, in the edges, you always put ones. And then over here in this middle term, what we would put is 1 plus 1. This one plus this one gives us 2. Okay, we do the same. We put 1 in the edges, then we have 1 and 2 gives us 3. 1 and 2 gives us 3. And then we do that one more time. We put 1 on the edges, and then we do 3 and 1. It would give us 4. 3 and 3 gives us 6. 3 and 1 gives us 4 again. And you notice a pattern. You can do that infinitely. So this first one would correspond to a power of 1. This one would correspond to a power of 2. This one to a power of 3 and a power of 4. And if we notice, in the power of 3, we have 1, 3, 3, and 1. And all of these match up with the eventual expansion that we did using FOIL. As you can see, all these numbers match up. So that is how you get the coefficients with Pascal's triangle. Now, how do we get the actual numbers or the powers of the terms? So the way that we do that is that if you notice here in the a term, it goes power of 3, then power of 2. So 3, power of 2, power of 1, and over here we have an a to the power of 0. And then for the b term, we start with a b to the power of 0, followed by a b to a power of 1, a b to the power of 2, a b to the power of 3. So what is happening essentially is that in an expansion, let's make some space for it. So in any expansion a plus b to an n term, the way we find the power of the coefficients is that we simply take this first term and we put it to the power of n times this term to essentially, well, the first term will be 0, so we don't even have to write it out. And then we add it, and then in the next term we're going to have a to the power of n minus 1 times b to the power of 1, obviously. And then you would keep on doing that, right? So n minus 2, and then b to the power of 2, until eventually you would get a to the 0, and whatever the number of b is, that's the final number. So that's how you get the other power. Now what you will actually have in the IB exam is this right here, the binomial theorem formula. This looks very complex, but what it's basically telling you is the same as what I explained before, right? So if you have a power a plus b to the power of n, you're simply going to have the first term will be a to the n power plus the coefficient, which you can find either Pascal's triangle if it's a small coefficient, or using the combination as I told you. So you put the combination n to the 1, or n choose 1, which can be done by the calculator or through another method that I will teach in a later video. So you put that, you put a, and then n minus 1, because we remember that the power in the a term is counting down, and then we put b to the 1. And this essentially repeats, right? Simply increasing the number. So n choose 2, a, n minus 2, b, 2. And this repeats for as many terms as necessary until you arrive at b to the n power. This is the same that I explained. What you need to remember right now is that NRC gives you the coefficient, the power on a counts down, and the power on b counts up. All right, so let's do an example problem to put this into context. So let's say that we're given x plus 2 to the power of 3. And it wants us to write the full expansion. So first, we would do the Pascal's triangle, right? We start with our triangle of 1s, then we do 1, 2, 1, then we have 1 plus 2 is 3, 2 plus 1 is 3, and then the 1 and the edge again. So we know that this right here will work for any power of 3. Okay, so we know our coefficients, right? So we can write the coefficients down. So the 1s we can ignore, we can do 3, this will be a plus, and then we can also write a 3 here. And then we have a 1, which you can also ignore. So according to the general formula again, we'd first know that the a, or in this case x, which we can put here, a and b. So the a counts down, the b counts up. So in this case, x to the n, or x to the 3, would be our first term with a coefficient 1. Then for the second one, we would have